Now we are going to find the torque acting on an electric dipole which is placed in a uniform electric field. To that we are considering a uniform electric field. This is a uniform electric field. This is a uniform electric field. Then we place a dipole on this uniform electric field. We already know that a dipole has two different charges. If this is positive, if this is negative charge Q, then this is positive charge Q. These two charges are separated by a small distance 2a. This is distance 2a. Then a force is generated on this dipole due to this uniform electric field, because this dipole is placed on this uniform electric field. So a force is generated on this dipole. A force is generated on this dipole. A force is generated on this dipole. The equation of force is charge into electric field. This is an equation of force. At positive charge, the force is generated on this direction, and at negative charge, the force is generated on opposite direction. These both are same charges but on different direction. At positive charge in this direction, the negative charge in the opposite direction. These forces are same but they are in opposite direction. So a rotating force is generated on this dipole. This rotating force is called torque. So a torque is generated on this dipole. A torque is generated on this dipole. So the dipole is rotated. So the dipole rotated. So the dipole will rotate till it become parallel to electric field. So the dipole rotate. The rotating force or torque is called torque, is equal to force into perpendicular distance. We already know the force. Force is charge into electric field. What is perpendicular distance? This is a perpendicular distance. This length is the perpendicular distance. When we complete this, we get a triangle. We give the name ABC. This A, B and C. Then this side BC is the perpendicular distance. So we can write as torque is equal to, force into BC, force into the side BC. Or what is force? Force is charge into electric field, into BC. Then we want to find the side BC. If we take this angle as theta, then what is sine theta? Then sine theta is equal to opposite side by hypotenuse. Here the opposite side is BC. Then BC divided by hypotenuse is the length of this dipole is 2a. Hypotenuse is 2a. Then BC, the sine theta is equal to BC divided by 2a. Then what is BC? BC, the side BC is equal to 2a sine theta. Then BC is equal to 2a sine theta. Then we get torque is equal to, Q E 2a sine theta. QE 2a sine theta. Then as what is 2a into q? Then 2a into q. 2a into q. 2a into q is dipole moment. It is dipole moment. 2a into q is dipole moment. So we can replace that. So the equation will become torque is equal to. So equation will become torque is equal to dipole moment P into E sin theta. Dipole moment P into electric field E sin theta. This is equation of torque. This equation of torque act on this dipole when it is placed in a uniform electric field. This is equation of torque which is placed in a uniform electric field. When we write this as in the form of cross product, we get torque is equal to P cross E. The torque is the cross product of dipole moment and electric field. We can write in this form. When we get the maximum value of this torque, when sin theta is equal to 90 degree, when sin theta is equal to 90 degree, sin theta is equal to 90 degree means value is 1. When we get the maximum torque, then torque is equal to Pe sin theta. Pe sin theta, when sin theta is equal to 1, when we get the value of torque is equal to P into E. When sin theta is equal to 90 degree, we get the maximum value of torque.